Okay, so for the following circuit, we have to find the following. We have to find I2 at 0. Then we have to find the formulas to represent these ones. And we're given the formula for I1, and we're told what I at 0 is going to be equal to. It's going to be equal to 1.4. So let's set the time to be 0. So I1, it's going to be 0.6 e minus 2t. And since t is 0, this is going to be 0.6. Okay? And now we're told to add 0, it's going to be 1.4. Now this is enough information to find I2. So we see as I enter the node, I1 and I2 leave the node. So that means I is 1.4 minus 0.6 equals I2. I2 at 0 is equal to 0.8 amps. So that's our first bit done. Okay. Now let's try and solve the second part. So we have to find an equation to represent I2 so we have to find an equation to represent I2. So to find the current passing, so we see I2 is passing through an inductor. So to find the current passing through an inductor, it's this like really like scary looking formula. It's 1 over the inductor, the integral from 0 to t of the voltage at that inductor, dt plus I ot. Okay, so I'll guide you through the formula. So L here will be 3 henries. We have to find a formula to represent the voltage through here. So we know what the voltage passing through the inductor is going to be. It's going to be V1. Okay, so this V1 represents the voltage at this point, but it's also representing the voltage at this point as well. Okay, so since we know V1 is the voltage here and here as well, we can use this to our advantage. So to find the voltage passing through an inductor, it's the inductor value times the change in current over the change in time. So we know the current here. So we know what I1 is. Okay? So it'll be 6 Henry times the derivative of 0.6 e to the power of minus 2t. And this will give you, give me a sec, minus 7.2 e minus 2t. Okay? And we plug that value into here. Okay, so it will be 1 over 3 integral from 0 to t of minus 7.2 e to the power of minus 2t dt. Okay, now this one, we're gonna this one's gonna be our initial IT value. Okay. Oh yeah, and remember this is to find I2t. Sorry, I should have included that. So I2 at 0, and I2 at 0, recall it was 0.8. All right. Now we'll do 1 over 3. Now we have to integrate this. So if you know your integrations, it should be 3.6 e to the power of minus 2t from 0 to t plus 0.8. Okay, wait, hold on. Let me bring that here. Okay, now so 1 over 3, 3.6 e minus 2t minus 3.6 minus 2, sorry, 3.6 e minus 2, 0. Okay, plus 0.8. Now, so that just simplifies to 3.6 e minus 2t minus 3.6. And then we divide the bracket by 3. So it's 1.2 e minus 2t minus 1.2 plus 0.8 and that's minus 1.2 e minus 2t minus 0.4. Okay, so that's your formula for I2 at t. So let's put that somewhere here. Okay. Oh yeah, and it's in amps. So now let me erase all of this. Okay, so we have this part done. We have this part done. Now we have to find the formula to represent this one. So this one's going to be a little tricky, but notice how it's close to this value here. So this the voltage between these two terminals, and we can start by trying to find the so let's try and find this voltage first, okay? So this voltage will be equal to the inductor times di over dt, okay? So so how are we going to find v? Sorry, what's this L value going to be? So this L value is actually going to be the Thevenin inductance. So pretty much it's going to be all of the inductors combined. So these two, they're in parallel. So it'll be 1 over 3 plus 1 over 6 to the power of minus 1. So it's 2 henries here. Then 2 henries plus 8 henries. It's 10 henries. So this will be 10. Now, oh wait, I just realized I just made a big mistake. Apparently we don't even have to do that because I just realized I is equal to I1 plus I2, and we know what I1 is, and we know what I2 is. I1 is 0.6 e minus 2t plus I2, which is 1.2 e minus 2t minus 0.4. And this will give you your IT value, okay? So IT will be equal to 0.6, hold on, so it'll be 1.8 e minus 2t minus 0.4 amps. Alright, so my apologies there, sorry. I'm like doing this question as we're all going along. Okay. Alright, so that's this part done. Now let's try and find V1t. We actually found V1t a while ago. So that's another thing that we're done with. V1t. And let's try and find this V value. We'll start where we left off. Remember, we were trying to doing something about the inductance equivalent. So V t will be equal to L times di over dt. This L will be the inductance equivalent, which recall it was 10. Then this I value will be the current nearest to it. So it's going to be this. So we're just going to plug this in here. So it'll be the derivative of 1.8 e minus 2t minus 0.4. And that gives me minus 3.6 e minus 2t. And that's just minus 36 e minus 2t. Alright, so that's that one done. And finally, now we just have to find V2. V2 is actually going to be easy because if we do a mesh here, the sum of all the voltages should be 0. So minus V plus V1 plus V2. See, so minus V plus V1 plus V2. So rearranging, it's going to be V1 minus, sorry, V minus V1. V is minus 36, E minus 2T, minus V1, which is minus 7.2, E minus 2T. And that gives me minus 28.8, E minus 2T. So those are your final answers.